Alright, and in this tutorial slash homework, I'm going to ask you to draw a diastereomer of this original molecule. Alright, so in a previous video we drew the enantiomer of this molecule. You can go back and watch that. So, a diastereomer is a stereoisomer that is not a mirror image. Okay, so you've basically got 5 carbons here. The connectivity has to stay the same. Alright, so it has to look like that. It could be turned over, whatever, but it's got to look like that. You have to have, it has to be 3-methyl-2-pentanol. Alright, so if we do this where all the atoms overlap, like I could take this bottom figure, overlap it with the top figure, and aside from wedges and dashes, they would overlap exactly. So if I change the configuration at both of the chiral carbons, there are 2 chiral carbons. If I change the configuration at both, then I would get the mirror image. I would get the enantiomer. That's what I did in the last video. So the trick is to get a diastereomer, you want to change one chiral center. You want to change at least one chiral center. You can change more, but you want to change at least one, and you want to have at least one stay the same. Right? So in this case we have 2 chiral centers. Maybe I should have asked you to identify the chiral centers. Do that. Hit pause and identify the chiral centers. Alright, you're back. Methyl's not chiral. CH2, 2 hydrogens on it, it's not chiral. Methyl is not chiral. This carbon has an OH, an H not shown, a methyl, and a CH. It's chiral. This carbon, the 3 carbon, has a methyl, an ethyl, and a CH, and an H. So that's 4 different groups. It's chiral. So I've only got 2. I have to change at least one, and I have to keep at least one the same to have a diastereomer. So one has to change, one has to stay the same. So let's just keep the OH the same, and now let's make the methyl. I just drew the same structure, didn't I? Let's change the methyl. Alright, so this is a diastereomer. The chiral carbon with the OH stays the same configuration. The chiral carbon with the methyl changes. So at least one changes, at least one stays the same. They're no longer superimposable because there's been a change, but they're also not mirror images because not everything has changed. So this is a diastereomer.